Hi guys, it's Mrs. Anglade. Today we're going to be talking about lesson 8.5 and this is part 1 of it. So what we're going to talk about today, if you read when you picked up your packet, it says like and unlike, combining like terms. Our goals for today in this lesson is you're going to develop models for algebraic terms, you're going to use models to combine like terms in algebraic expressions, and you're going to combine like terms in algebraic expressions. Okay, so now today if you take a look on the right hand side of that packet, what you're going to have is not only your x's and your y's and your 1's that we've been talking about, but now we're going to add our x squared. So what do I mean by that? We have been talking about our x and our 1, right? But now what we're going to talk about is today we're going to use our x squared. Our x squared. Now, why is this x squared? Because if you think about, look at what you notice. If this is x units long, and that is how long my square is and how wide it is, right? This is x. This is also x. The area of this square represents x squared. So that's why we call this x squared. Now, there is a y squared, just like there was a y. And so let me show you what that looks like. The x squared looks like this. Hold on, okay, so the x squared looks like this, but when I look at my y squared is a little bit smaller than my x squared. Okay, so here's my y squared. Now, why is it y squared? If you take a look at the y that I have for you, that is one of the sides of my square is y long, and the other side of my square is also y long, and so that is why we call this our y squared. So I just wanted to kind of show you that, so that you can kind of see where that comes from, okay? Unfortunately, again, we don't have our algebra tiles that represent that. So when we go to sketch it today, what we just want to make sure is that when we sketch it, it's just the square is just a little bit smaller than the x squared that we do, okay? All right, so part 1 asks us, okay, so part 1 asks us to say, what are the dimensions of each of the tiles? Okay, so remember this longer one represented x. So remember this dimension, this was x units long. And if I take my yellow, it's the same length as my 1 yellow. So this is x long and this is 1. That's why we call this x, right? Because 1 times x is x. If this is y long and this is 1 unit y, that's why we call this a y, because 1 times y is still y. If this is 1 unit long times 1 unit, that's why we call this 1. Remember what we called this? This was y squared because the dimensions of this is y and y. So this is y squared, right? Because the area is y times y, or y squared. And then part E, the dimensions of this is x and x. So this is x squared, right? All right, so what we're going to do today is we're going to combine like terms together. So let's see what they want us to do. Represent each algebraic expression using algebra tiles and the operation symbols. Then sketch your model. Okay, so what they want us to do is with our algebra tiles, we're going to represent 3x squared plus x plus 2. So what is that going to look like? 3x squared is going to be 3 of our x squared, right? I already forgot what it was that the next term was. Plus x plus 2. All right, so what is our x going to look like? It's going to look like this. And what is our 2 going to look like? Our 2 is going to look like that, right? So this is 3x squared, right? Remember what that coefficient does. That coefficient tells me how many of my terms that I have. Well, if this is x squared, I have 3 of those, plus x plus 2. All right, so let's sketch that. So what we're going to do is represent our x squared with our little squares. So 3x squared plus x plus 2. Okay, and they do want us to use our operations in between there. Okay, so what does the next question say? Part B, 2 plus x squared plus y squared plus 1. So let's just see if we can do it without our algebra tiles. You can use your algebra tiles if you want. All right, so x squared is going to look like this. Remember, y is smaller than x, so y squared is also going to be smaller than x squared. Okay, so this is x squared plus y squared plus 1. Okay, now it doesn't tell us to combine the terms together. Maybe it'll tell us to in just a few minutes. No, it never does. Well, if we wanted to write this, in simpler form, it would be x squared plus y squared plus 3, right? Okay, but they're just asking us to sketch it. All right, so what would this look like? This would look like 3x. So here's my 3x. I'm going to make it a little bit longer because I do have a y in here, right? So 3x plus x plus 2y's. Okay, make sure that these x's are longer than the y's, right? And this is going to be 5x plus 1 plus y squared plus 3 plus 3. So what is that going to look like? It's going to look like 5x's, right? So 5x's plus 1 plus y squared, right? Y squared plus 3. The next one, E. Go ahead and do E. Go ahead and pause the video and do E and see if your sketches represent my sketch. All right, so this is the expression that I got for part E. What I did notice though when I was doing this is I made a mistake back here. This y squared, I don't know what made me think that I had 2 of those. I only have 1 of those because that's going to affect my answer that I write down on part 3 that says, which of these expressions in part A through E have different terms, but they have the same number of identical tiles, like the same number of tiles. So what they want though is, let's go back and look at A. I have 3 of these x squared plus 1 of these x's plus 2. Do any of these terms match like the number of terms or the number of tiles? And the answer is no. Let's take a look at this one though. Let's see. I have 1 of my x squared and 1 of my y squared and 1 of my tiles. Do I have identical terms, but identical numbers, but the terms are different? And that is true. I have 1 of x squared, 1 of y squared, and 1 of 1. So we're going to say B on that one. What about C? Do I have anything that looks like I have 3 of that, 1 of this, 2 of that? Nope. But what about this one, the one I messed up on, right? I have 1, 1, and 1 y squared. So I have matching there, so parts B and D. And what about this one? Let's see. Oh, look, I have 3 x's here and 3 1's here. And, oh gosh, I did it again. Look at that. And that's it on that one. So which expressions in part A through E? So I think I found that it was B had some different terms with identical tiles. I believe it was part D that had identical tiles and E that had some identical tiles. All right, rearrange the tiles in question 2, part C, so that there are only 2 terms. Sketch your new model, include the operation symbol. So in question 2, part C. So let's go back and see what that is. Okay, so we had 3x plus 2y. So this is kind of combining like terms, right? So if I had 3 x's plus 1 more x, together I have what? 4x plus 2y, right? So 4x plus 2y. So here's my 4x, and here is my 2y. Okay. Rewrite the algebraic expression represented. 4x plus 2y. Could you rearrange those tiles so that there's only 1 term? Explain your reasoning. Go ahead and answer that right now. Pause it if you need to. Hopefully you said in part C that no, I cannot rearrange those tiles because they are not like terms, right? And that's exactly what we would answer for part D. What are the terms that can be combined called? And we would call those like terms. All right, they want you to go back to part B. So part B. So when I look at part B, I notice that I have 2 plus x squared plus y squared plus 1. So they want the fewest possible. So if I'm going to combine this, what I'm going to do, because it asks you to rearrange the tiles, it looks like I'm going to have an x squared. I'm going to write this right over here because I'm kind of out of room. And I'm going to have a y squared, right? And then when I combine them together, I get 3 of those, right? And so part 5, part B says, write the algebraic expression represented. So I have an x squared plus y squared, and then combined together gives me 3, right? Could you arrange the tiles so that there was only one term? Explain your reasoning. So kind of like the same reasoning that I had from before, right? I can't combine those together because the terms are not alike. Okay, I want you to go ahead and do 6 part A on your own. Go ahead and pause the video, and then we'll go ahead and take a look at what your new model will look like on part D. So pause the video and do this on your own. All right, so in 6 part A, I came up with the following sketch. I'm going to combine that 3 plus 1 together. Hopefully you went ahead and did part B, but if you did not, go ahead and do that right now. It says write the algebraic expression that you represented. So I had 5x plus 1y squared, right? So we just write y squared plus 4. Can you rearrange the tiles so that there are fewer terms? Again, we can't combine any of those because they are not like terms. That's the whole purpose of this lesson, is to make sure that you understand that I can't combine those terms together. They don't look alike. They're not the same shape. I can't combine things together that are not alike. So they want you to go ahead and do part E. So I want you to go ahead and do the rest of number 7, all the parts, and I'll come back to you and show you my answer. So go ahead and pause the all right, so 7's part A and part B. This is what I got for a sketch, and this is what I got for an answer of my algebraic expression. And then again, ask, could you rearrange the tiles so that there are fewer terms? Again, you know, they want you to explain why you can't combine those together. All right, let's go ahead and take a look at number 8. Whoops. Number 8 says, they're representing the algebra tiles, and they're going to represent this 3x plus 2, and then out to the side they're just going to say that that's 2 groups of them, right? 2 groups of 3x plus 2. And from that quantity, I want to take away 3. So that's how they're sketching that algebraic expression. It says use the distributive property to rewrite the expression without parentheses. So these 2 groups of 3x plus 2, do you agree, would be 6x plus 4 minus 3. So I'm going to have 4 yellows here, and from that, I want to take away 3 yellows. So what is it going to be if I take away those 3 yellows? Part B wants us to model your new expression using algebra tiles and operation symbols. So we said that this was going to be 6x, right? And what if I'm going to start with 3 or 4 yellows, and I'm going to take away, I'm sorry, what did I say? 4 yellows and take away 3 yellows. Do you agree that I'm only going to have 1 yellow left, right? It says rearrange the tiles to reduce the number of terms to the fewest possible terms. Then rewrite the algebraic expression that is represented. I think what I forgot to do is, sorry, I think this is what they wanted me to do. They wanted me to show 6x plus 4 minus 1. That's what they wanted us to do, because now what they're wanting us to do is to reduce the number of terms. So this is where they want us to say the algebraic expression would be, sorry, not 5x, 6x. 6x, and then this 4 minus 1 is plus 3. Okay, so 6x plus 3. All right, so what they want, so we're going to go ahead and stop there. Okay, you should have enough information from this lesson to go ahead and do your homework that you picked up. We're going to go ahead and start with 9 starting tomorrow, and then we will finish this part of the lesson tomorrow. So hopefully this part of the lesson made sense. Hopefully it wasn't too bad. Part C, actually, if you did want to simplify that to lowest terms, I could break that up into 3 groups. So I really could simplify this by 3 and say that it was 2x plus 1 if you wanted me to. But it didn't ask us to do that. It was really 3 groups of 2x plus 1 if we wanted to factor it out, but it didn't ask us to, so we won't do it. We'll just keep it as 6x plus 3, but just a little bit of tidbit of information. So we're finished for the day, so make sure you go ahead and work on homework or work on any Muse math that you might have still to finish. All right, talk to you soon. Bye.